So what's up guys, today we are going to solve the problem 1703, minimum adjacent swaps for k consecutive ones. This is considered as a hard problem, but trust me guys, I will make this problem cakewalk for you. You will be able to code on your own after going through this whole video. Okay, so what question says that I will not read the statement, just will tell you what you have to do here. Nums array is given that will consist only 0 and 1, and there will be given k equal to 2, right? So this k tells you that you have to collect two consecutive ones, and you have to return what is the minimum move that will take, right? For example, you have to collect two consecutive ones. What you can do, you can take this one and you can shift at this point, so there will be two consecutive ones, right? And here you need to three consecutive ones, so there are two already, so you have to shift this one to this side, right? So you have to do all these things, right? And here there is k equal to 2, means two consecutive ones required, so there are already two, so this is 0, right? And if we see the acceptance rate, so it is in fact a very hard problem, as the submission rate tells us, right? So okay, so first of all, the problem is easy. I will make sure that this is easier for you, and let's get to the board. So without any wasting time, so let's see what we have to do here. So this is problem number 1703, and we have taken an example. So uh, in fact, when I solved this problem, this was the example where my problem was getting stuck, my solution was getting stuck. So that's why I took this example. In fact, when I was solving, I tried other algorithms, I tried other approaches, but that didn't work out. So I tried this one and it ran successfully. So I will explain you how I actually solve this problem very easily, right? So let's say k equal to 7, and we are given an array, right? So we have to collect, so what we have to do here is we have to collect 7 consecutive ones, right? We have to collect 7 consecutive ones, right? So I can take collecting, it could be like 1 1. Let me take another pen here. I can take it as 1 1 1 1 1 1 and 1. I can collect right here. I can collect anywhere, right? I can collect anywhere. What I did is, I took the indices of wherever the one is present. So you can see that one is present at 0, and then 3, and then 5, and then 6, and then 7, 9, and 10, right? Okay. So one more thing guys, what if I start collecting, what will be the starting point for me, right? Suppose what I'm trying to say, just understand it. Let's say if I collected, let's say something like this: 1 1 1 1 1 1, right? 3 3 6 and 7. Okay. If I collected all the ones at this way, so my starting point will be at the 4, right? Okay, my starting point will be at the fourth index, and it can also start from 0. So I can say that the starting point of all connected sub starting point of consecutive ones, 7 consecutive ones, starting point of 7 consecutive ones could be from 0 to n minus k, where n is the length of the uh, what we say is length of the array, right? Length of the array. So now what we can do is, you can see that the length of this array is 11. 11 minus 7, how much? We got 4, and we can see that 4. Okay. Now other thing, right? So I hope that the starting point of the all consecutive ones is clear to you, and that is going to be 0 to n minus k. And the second thing what I'm going to tell you is, in this problem what I will do, I have to calculate how many jumps did we make to collect every consecutive ones at the side, right? We have how many jumps we collect, how many jumps we took to make all 7 ones in consecutive order, right? Okay. So in this question what I can do is, What I can do is, I will count the jumps to to calculate, I will count the jumps I took to move to collect all ones at a particular index, and then from that index I will spread it. What did I say? Just understand. Let's say I have given is 10101, uh, right? Let's say this is our example, right? So what I will do is, I will, let's say this is a point, let's say this is a point, let's say this is a midpoint, right? So what I will do, I will calculate all the jumps I took to collect all the, and let's say k equal to 3, right? Let's say k equal to 3. What I did is, I will count all the jumps I took to calculate, to collect every ones at a particular point. Let's say I collected all the ones to the midpoint, right? So if I collected all the ones to the midpoint, how much jump do I need to take, right? So I need to take here two jumps, and here I need to take two jumps. All in all, I took total jumps equal to 4, and these total jumps is equal to the jumps I needed to make to collect every ones to a single point, to a midpoint. Because I imagine, if I collect every point at a midpoint, at a median, it will be the lowest cost. Okay, so what I did is, I collected every ones to the midpoint, and now what I will do, I will re-separate it, right? How would I do that? In my case, it should be something like this. It should be something like this, right? And let's say this is a midpoint. Let's say this is a midpoint. Oh, this is the midpoint. This is the midpoint, and okay. So at this point, at this moment, I have here two ones, and the total jumps I took is 4, right? At this point, all my ones are here. At this point, all ones are at my midpoint, and we already took 4 jumps to collect every ones to the midpoint. Now I have to, distribute it around the radius, right? I have to distribute it. So I need to put this one to this point and this one to this point. Then how many jumps do I need to take? I need to take, for this one I need to take 1 jumps, and for this one I need to take 1 jumps, and then I will subtract from the total jumps I needed to take to collect all the point at the midpoint, minus total jumps I need to make to spread it around the radius of a midpoint. So that will be, if I spread this one to this point, and if I spread this one to this point, for this point I will need to take 1 moves, and from this one I need to take 1 moves. In all, we need to take 2 moves, and then I will minus it, and the answer will be here 2 jumps, right? So I will use this approach. First, what I will do, first I will calculate the total jumps. First I will, I will collect all the ones to the midpoint, right? First of all, I will collect all the ones to the midpoint, and then I will redistribute it, right? So I will write it, collect all ones, and then redistribute. Okay, so what will be the midpoint? How would I decide the which midpoint should I collect all the ones at? How would I decide which midpoint should I collect all ones at? So that midpoint will be decided by this total jumps, right? If this total jump is smaller, then the total answer will be also smaller, right? Because it is also subtracted by total minus 2, total minus something. Let's say this is subtracted by total. If this is total minus something, if this total is smaller, then total minus something will be also smaller, right? So I will decide that midpoint by total jumps that need to make to collect all the ones to the midpoint. So now simple. So first of all, what I will do, I will collect all the one to the midpoint. First of all, I will collect all the ones to the midpoint wherever minimum jumps need to be taken, and then I will redistribute it around the radius. Simple. Okay, now moving to our question. What I did is here first of all I take the I, so I can be start from here and it can go up to here because k equal to 7. So if I take 7 consecutive at the end, so I can be moved from here to here, so I equal to 0 to n minus k, right? And here let's say okay fine, if let's say if my I is here, right, then how can we find the midpoint? How can we find the midpoint? Midpoint will be I plus k divided by 2, right? If I take integer division, it will be midpoint, right? Now we have to calculate the total move required to shift all ones to the midpoint, right? Okay, and then I will take the minimum total, as I already told you that we have to minimize this total so that total minus something will be smaller, right? So now I am trying to calculate is minimum moves that I require to collect every ones to a particular midpoint, right? Now what I have done here, I have written out the indices of all the ones, and then let's say this is a midpoint, right? Let's say this is a midpoint. Then how can I calculate the total jumps? It will be mid minus p1 plus mid minus p2. You can see that if this is a mid and this is p1, p2, p3, p4, mid minus p1 plus mid minus p2, and then p3 minus mid because p3 is greater than mid, and then p4 minus mid. If I sum up, it will be mid cancel out, mid cancel out, mid cancel out, mid cancel out, and it will be p3 plus p4 minus p1 plus p2. And if you see that and this array is the indices, it is the array of indices of ones, right? And if I sum it up, this will be p3 plus p4 minus p1 plus p2, and it is nothing but prefix sum at the left point of the mid and prefix sum at the right point of the mid, right? Okay, so but there could be this could be at this point after the mid, it is equal to 2 and this is also length equal to 2, right? But this is not necessary, it will be always same. At here this is 2, size is 2, but some point mid could be at this point if array is bigger. In that case, right, I will come at that point, right? So now calculate the minimum moves to shift all the ones at the midpoint. So how can we do that? So this is our minimum moves we have already calculated. Here is, this is our moves to collect all ones at mid. And when kab when index array length is odd, index array length is odd. But what happens when index array length is even? In that case my mid will be this point. Let's say this is midpoint, and let me write it clear. This is p1, p2, p3, and let's say this is mid, and p4 and p5, right? And if this is our mid, then how will we calculate the total move, total jumps? This will be mid minus p1, this will be mid minus p1 plus mid minus p2 plus mid minus p3 plus p4 minus mid plus p5 minus mid, right? And in this case mid will be cancelled out, but one mid will be remaining, because you can see that the size to the left of array and size to the right of array in this case will not be equal, right? In this case our one mid will be remained. So in this case what will happen is p4 plus p5, that is prefix sum to the right of mid minus prefix sum to the left of mid plus extra one mid, right? So what we have understood so far is if if array length, right, if the array length of indices of 1 is even, in that case the length of this side and the length of this side around the mid will be same. In that case what I have to do is prefix sum of this thing and prefix sum of this thing, I have to just subtract this and I will get the jumps need to be taken to collect all the ones to the midpoint, right? But if it's odd, this is if this array will be even, if this array will be even, then my mid will not be at the center point, so it could be up to here or this could be up to here. So in that case we have to add extra mid value, right? You can see here, we had added a extra mid value when my array length was even, right? When my array length was even, in that case we have to do this. So far what I have done is we have to calculate the total minimum jump to collect all the ones to a particular midpoint. Okay, so let's code it up whatever I have told you. So let's code it up, and after coding the total jumps needed to collect all the ones at a midpoint, and then after that I will subtract the jumps that need to be distribute all the ones around the midpoint, right? Now first of all let's code up the total jumps that is required to collect all one at a midpoint, right? Okay, so let me come here. After doing this I will redistribute it. Okay, so what I have to do here is I'm going to code in Python. So first of all I have to make an array for calculating or indices of ones, right? So what I will do, uh, equal to I for I num in enumerate of nums if num equal to 1. So I'm coding in Python, so you can code in whatever language you want, because logic is more important than coding. And as you know, as we calculated the prefix sum, so I have to also make a prefix sum, and I will keep a dictionary to store the prefix sum with the indices. And by default I'm taking as a 0 for the -1 indices, right? This is the default case. And then for I in range of n, prefix sum of I uh, prefix sum of I equal to prefix sum of I minus 1 plus uh, uh, position of I, right? So after, you know, as soon as I make this array of indices of ones, we have to forget the nums, because we are not doing anything with the nums, right? We are not doing anything with the nums. All I need to care about is the this array. Okay, and now I need to calculate the minimum jumps need to make minimum jumps to collect all the ones to a midpoint. Okay, so how would I do that? First of all, let's say default case total moves equal to system dot max size. So this will store as a max point. And now if you remember, can you tell me what was the I means starting point of the I? So let me go back to my drawing board. Now you can see that if I collected all the ones, this could be go from this could be go from starting to this point. So I told you that I could be from 0 to n minus k. And what is I? I is the starting point of all collected ones, all collected k ones, right? Let's say k is equal to 7, then I is the starting point and ending point of the all collected ones. So it could be from 0 to n minus k, right? So now what I did is here is I will start it from 0 to n minus k. Okay, so for I in range of 0 to n minus k and plus 1, because it always go, if I plus it 1, if this is 0 plus n plus 1, then it goes from 0 to n. Okay, so now what I will do, I will first make a midpoint. So it will be I plus k divided by 2, and then I have to calculate the right prefix and left prefix. So right will be prefix sum of I plus k and I plus k minus 1 minus prefix sum of mid. If you don't understand, let me explain it a bit. You might forget it, so let me explain a bit to the drawing board. So let's say I have to calculate this. Let's say I have to calculate this prefix sum and this prefix sum, right? I have to calculate. So what I will do, I will take the prefix sum of this and minus prefix sum of this, then I will get this point, right? If I take the prefix sum of last one and the mid one, this I will get this one. And if I calculate this prefix sum, then what I have to do is I will take the prefix sum of this one and prefix sum of, if this is I point, I minus 1, I will remove, then I will get this prefix sum. Is it not simple? Okay. So now I'm going to do the same thing here. I'm going to do the same thing here. Uh, so we have found out the left, right, and now we have to find the left prefix sum of mid minus 1 minus prefix sum of holy I minus 1, right? And then total moves will be minimum of total moves, and as I already told you that we are checking for every mid, and we will store the minimum total that is required to collect all the point to the midpoint, right? And this will be my right minus left plus, as I already told you, we added an extra mid when it was odd. When it was odd, I had, when it was even, we had added a extra mid. So I will do that, right? So plus uh, position of mid, as we have to add that index point, mid index point, right? Mid index point, and that will be if k was even, only then I will add it, otherwise I will not add it, right? So what I said is I have to make this in a parentheses, and let me make it a bit bigger. Okay. So what I did is in total moves I am trying to get the minimum total moves, and right minus left plus I added a mid, in index of mid when it was even, otherwise I will not add it, because in the case of odd there will be center point, but in the even case there will not be a center point, so we have to add an extra mid, which we have already seen it, right? And then what I will do is, okay, fine. So at this point, my total move will tell me that what is the minimum move I took to collect every consecutive ones to the center point, right? And now we have to distribute it. So, okay, let's come to the coding part. Oh, drawing board. Okay, so we have already seen it in the example. We have already seen it that we all first calculated the total jumps I needed to take to collect all the ones to a midpoint, and then what I did is I distributed it around the mid, right? I distributed it around the mid, and then the move that I took to redistribute it around the mid, I subtracted it, right? So now what I have to do is, so at this point I have found out the total. Now I have to collect this one. And what is this one? This is the move that I need to take to distribute it all the ones around the mid. Okay, so now let's come to that point. Okay, okay, so at this point we have done it, right? So now the question says that, but we don't have to collect all ones at the mid, we have to split all the ones around the mid. Okay, now let's distribute it. So let's say this is our mid. Let's say this is our mid. In fact, this is our mid, and we have to split all the ones around the radius. I have to all the ones around the radius. So what I have to do, if I spread it here, right? If I spread it here, I need to take one moves. If I spread it here, I need to take first this one and then this one, two moves. If I spread it here, this will take three moves, and same goes to the right side as well. But in the case of, in the case of even in the case of even, I will get an extra block, because I already told you that if the array length is odd, I will get a center point, but if this is even, I will get an extra block, right? Because we cannot take two midpoint, right? We cannot take two midpoint, we have to take only one midpoint. So I will get an extra block, and that block will be radius plus 1. And what is radius? So I took this distance as a radius. In fact, I need to make it using this color. So this is radius, because radius is the same side, same size, right? If this is a mid and this is a radius, and what the radius will be, right? What the radius will be. So let's say I had to take k equal to 7, then let's say this is 1 2 3 4 5 6 7, right? 7. So radius will be midpoint, and that is k equal to 4 here. So I have to spread six ones around the midpoint, right? I have to spread six ones around the midpoint. Let's say k was 8. Let's say k was 8, and at that point my midpoint would have been 4, right? And then how much we need to distribute? We needed to distribute 7 ones. So 3 on this side and 4 on this side, right? 3 on this side and 4 on either side, right? So that 1 will be radius plus 1, right? if this is if this distance is our radius, and this will be radius plus 1. So to distribute a point, to distribute ones at this point, I need to take radius plus 1 jumps. I hope that this is clear. And now what I have to do, I have to sum all these jumps. If I sum all these jumps, you can see that 1 plus 2 plus 3, 1 plus 2 plus 3, and it is consecutive. So it will be n into n plus 1 by 2. As we have to distribute both sides, so I multiplied with 2, 2 into 1 plus 2 plus 3, and that will be 2 into n plus 1 by 2, where n is equal to radius. In this case this is radius, right? But in even case, we have seen that in even case I have to move one extra, right? And that extra comes by radius plus 1, right? So I have added up, right? Here radius plus 1 I have added up. So now my answer will be total jumps to collect at mid minus total jumps we need to take to spread around the mid, right? We need to spread around the mid. Now let's code it up. I hope that the question is pretty much clear to you. Now let's code the whole thing. Now how would I find the radius? Radius will be k minus 1, k minus 1 divided by 2. Why I take a minus? Because if I take the minus, it will handle positive case, odd case and even case both. You can if let's say if k equal to 8, then it will comes out to be 3, right? If k equal to let's say 7, still it will come out to be 3. So I took minus 1 so that I can handle both the cases, right? And now I have to make total moves minus, I have to subtract it. Minus what I have to subtract? 2 into n plus 1 by 2, because we saw that that was consecutive. So it will be radius star radius plus 1 divided by 2. And that gonna be integer division, because radius into radius plus 1 is always going to be this is always going to be even, right? Okay, hope that this is clear. Okay, I will do that if mid was center. But in some cases mid will not be center. In that case I have to subtract something else. So what I will do, I will take positive plus, because I am subtracting it. I have to subtract one more thing, and that will be radius uh, rad, radius plus 1. And when would I subtract it? If k will be even. If it will be odd, I don't need to subtract anything. And at the end I will return total moves. Now let's run it. Hope that video didn't get longer. Oh my, where did I make a mistake here? I think parentheses mistake. um, so then in total moves I subtracted 2 into n plus 1 by 2. You know that number of moves that needed to spread it around. And then if the length will be even, then we have to add an extra radius plus 1. So I subtracted that as well, and then I returned the total moves. And if I run it, and let's submit it. My internet is slow. Okay, so this is 20% faster, but in other programming language, this you can, you can run it a bit more faster. So if you guys have any comment, please do let me know. Any queries, any question, please do let me know. And let me know what type of question, what type of topic you want me to explain for you. And have a good day. Thanks.